Good morning, all of you. My name is Shreya. In this video, we will cover internal first section A, statistical characterization of feedback data. Question number 1. View 3 more commonly used statistical measures for characterizing dispersion in student feedback data. Example, variation in teaching quality scores, lab facility ratings, or peer collaboration effectiveness. Discuss how these measures can be computed efficiently in large student databases. Answer. In analyzing student feedback data such as teaching quality scores, lab facility ratings, or peer collaboration effectiveness, understanding dispersion is an important as knowing the average. The most commonly used statistical measures of the dispersion include the range, the standard deviation, and the variance. As we know that to calculate range, we should know the minimum and the maximum value of the data set. The range shows the difference between the highest and the lowest feedback scores. To calculate range, we have formula max value minus mean value. Now variance. The variance measures the average squared deviation of each feedback score from the mean. To calculate the variance, we should know the mean summation of xi minus x bar whole square upon n. Here xi, which is our data set values, get subtracted from mean whole square upon n. N is the number of total data frequency. Now, a higher variance indicate greater inconsistency in student responses, such as large difference in how students rate teaching quality. Now, third, the standard deviation. Standard deviation is the under root of variance. To calculate the standard deviation, we should first find the variance and then under root the variance. So, we will get standard deviation. Standard deviation is the square root of variance, which is standard deviation is equals to under root of variance. It expresses the spread of data in the same units as the feedback scale. Example, a 5-point rating making it easier to interpret. Now to compute this large student database, we have some efficient computation which can be done with the help of SQL aggregate function, which includes the inbuilt functions like to calculate the average, we have average function. To calculate the variance, we have where pop function. To calculate the standard deviation, we have a standard deviation function. Now another computation method is to create by can be done by indexing and sampling. Creating index on feedback columns and using random sampling helps to compute approximate dispersion quickly when exact values are not required. Now, question number 2. Suppose that the student feedback rating on a scale of 1 to 100 on a faculty monitoring effectiveness is given in the sorted order. As here you can see that our data is given in the sorted order. Now here we have to calculate mean, mode, median, quartile, box plot, mid-range. So first we will calculate the mean of the given data. As we know that the data is in the sorted order. To calculate the mean, we have formula the summation of xi upon n. All the data points get added together upon total number of data points. When we apply the operation, we get our mean 30. Now, as we know that our data set has odd number of points, so here our frequency is odd. So to calculate the median, we have for odd data set we have formula n plus 1 by 2th the term for the odd data set. Here n is 27, we substitute n is equals to 27 in the given formula, then we will get 14 the term. So from the given data set which is already in the sorted form, we will see which is our 14th term. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 and 14th. Our 14th term is 25, so our median will be 25. Now next, to calculate the mode, as we know that mode is the most frequent data which occur in our data set. So as here, when we observe 25 and 35 both occur equal number of times into our data set, so our mode is 25 and 35. And this model is bimodal because we have two modes, so this model will be bimodal. Now calculate the mid-range. Mid-range, as we know the formula, mid-range is equals to minimum plus maximum upon 2. As we know that here minimum value is 13 and the max value is 70. Minimum value is 13 and the max value is 70. When we substitute this value, we will get our mid-range which is 41.5. Now to calculate the quartile 1 and quartile 3, we have the formula n plus 1 by 4th term. Here n is our 27 plus 1 by 4 which is 28 by 4th term which is 7th term. 7th term from our data set is 1, 2, 3, 4, 5, 6, 7. So our quartile 1 will be 20. Similarly for the third quartile, we substitute n is equals to 27. Here the 27 plus 1 28 by 4 which is 7th term. 7 into 3 which is 21st term. Now from the given data set we will see our 21st term which is 35. So our quartile 3 is 35. Now the 5 number summary. Now 5 number summary includes the mean value, max value, quartile 1, quartile 2 and quartile 3. Median which is our quartile 2. As we know that our minimum value is 13, max value is 70 and our quartile 1 is 20, quartile 2 which is median which is 25 and the quartile 3 which is 35. So our 5 number summary is 13, 20, 25, 35 and 70. Now to plot the box plot we require the mean max value and the quartile 1, 2 and 3. As our age and value are independent and dependent variables, we had plotted the graph which consists of the lowest value and the highest value which is our 13 and 70 and our quartile 1 which is 20, quartile 2 which is our 25 and the quartile 3 which is our 35. Now question number 3. Suppose that lab infrastructure satisfaction scores are grouped into intervals with the following distribution. As you can see here, data score range is given which is not continuous and the frequency of the student is also given. Now we have to calculate the median. To calculate median, first of all we have to make our range in the continuous form. So as you can see here cursor, here we make the our range in the continuous form by adding and subtracting 0.5 into current range. By subtracting 0.5 from the lower range, lower class and the from upper class we had added 0.5 to make our class range continuous. By doing so we had make our range continuous, as you can see by subtracting 0.5 from 1 and by adding 0.5 to 5 we get our range in the continuous order. Now as we know that the frequency which is given already in the question, from the given frequency we will calculate our cumulative frequency. As we know that initially our frequency is 200. When we add our full frequency 450 we will get the cumulative frequency. By doing this we will get cumulative frequency for all the classes. Now we have to find the median class. To find median class our formula is n by 2. Here n is the summation of frequency which is 3194. When we substitute it, our median class range is 1597. So which is close to 1500 frequency and whose class is 21 to 50. But we had make our class range continuous, so our class will be 20.5 to 50.5. and our class frequency is 1500 and cumulative frequency will be just above our median class, which is 950. Now to calculate the median, as we know that our formula is L plus n by 2 minus CF upon F into H, where L stands for the lower class boundary, n by 2, which is our median class, CF stands for cumulative frequency, H stands for class range, and F stands for frequency of a class. As here we know our median class is 20.5 to 50.5. So our lower boundary is 20.5 and our upper boundary is 50.5. We substituted the lower boundary, which is 20.5, n by 2. Here n is 3194 upon 2 minus CF, which is our cumulative frequency, which is just above our frequency, above our frequency, which is 950, and our frequency is 1500. And the height difference, as when we subtract both 50.5 minus 20.5, we will get 30 as our height of the class. When we substitute these all values into the formula, we will get median, which is equals to 33.44. Now next, in question number 4, we have to find in the Department of Lifelong Learning, a feedback survey collected both student age and their self-assessment of learning productivity percent of for the 18 student as year. Data is given for age and the percent productivity. Now we have to calculate the mean, mode, median, standard deviation of the given data for age and the percent productivity, and we have to plot box plot. Now for first age, we have to calculate the mean for the age. Simply we will add all the data points which get divided by total number of data points. When we apply this, we will get our mean, which is 46.5. As we know here, n, which is equals to 18, which is even. For even data set points, we will use the formula n by 2 at the term plus n by 2 plus 1 at the term upon 2. Here we substitute n is equals to 18. We will get our ninth and 10th term. We must Here data must be in the sorted form. As we know that age data is already in the sorted form, so we will find ninth and 10th term and substitute them. After substituting, we get our median, which is 51. Now to calculate the standard deviation, we should know the mean. As we already calculated the mean, now we have to subtract the mean from the following data points given in the question. As you can see here, these data points are already given. We subtract this data point from the mean, and then the square of the x minus x bar. By summation of this, we can easily calculate our standard deviation. Standard deviation formula is S is equals to under root summation of x minus x bar whole square upon n. When we substitute the value, we get our standard deviation, which is 13.218. Now from the given data, as we know that our 23 is the minimum value and our maximum value, which is 61. We already know the median, as before we had calculated our median is 51. Now we are calculating our first quartile. The formula to calculate it is n plus 1 by 4 at the term. Here n is 18. 18 plus 1, 19 by 4, which is 4.75, approximately fifth term. So our fifth term is 39 from the given data set. Now the third quartile, to calculate the third quartile, our formula is 3 into n plus 1 by 4 at the term. Here n is 18, 18 plus 1, 19 by 4, which is approximately 5. So our 15th term, 14th term, when we calculate it, our it is close near to the, when we take round of it, our 14th term. So our 14th term is 57. Using all these mean, max and quartile 1, 2 and 3, we had plotted this box plot. As we know that our minimum value is 23 and max value is 61. Quartile 1, which is our 39, and quartile 3 which is our 57 and the quartile 2 which is our 51. Quartile 2 and the quartile 2 and the median which both are the same. Now for the percent productivity, our given data is not in the sorted order. So here we perform sorting and arrange the data into ascending order. Now, first of all, we will calculate the mean of the given data. To calculate mean, we have formula summation of xi minus xi upon n. When we add all these data points upon n, which is 18, we will get our mean as 28.784. Now, with the help of this mean, we had calculated x minus x bar and x minus x bar whole square summation. Now to calculate the median, as we know that we have 18 data points which is even data set. So we will calculate this with the help of formula n by 2 at the term plus n by 2 plus 1 at the term upon 2. Here our n is 18 when we substitute it, and ninth and 10th term should be taken from the sorted data. So our mean is 30.7. Now to calculate the standard deviation, as we know our formula is x minus x bar whole square upon n minus 1. We substitute the value from this table and getting our standard deviation as 9.2544. Now from the sorted data we get our mean value, max value, median. Now calculating quartile 1 which is n plus 1 by 4th term. Here n is 18 plus 1 by 4th term, which is 4.75th term, which is approximately fifth term. So our fifth term from the sorted data is 26.5. Now third quadrille, similarly for third quadrille 3 into n plus 1 by 4th term, and substitute value here n which is 18. When we substitute this value, we will get 14.25 term. So which is approximately 14th term. From the sorted data, we will get our 14th term which is 34.1. Now with the help of this, we had plotted our box plot which consists of mean, max value and quartile 1, quartile 2 and the quartile 3. Now with the help of the given data, we had plotted the scatter plot. As you can see, these dot points are our data points for age and the percent productivity. Thank you.